everyone, welcome to our presentation. As you can see on the screen, our topic today is matrix acidizing. First of all, let me introduce our team. I am Melania Anastasia Kuryasin with my team Francina Ulan Lamere, Hasnawati Marito, Lydia Agnesa Malo, Muhammad Taufik Hidayat, Sabrina Adinda Dewayanti, Yandi Dolof Ratuwarat, and Yulianus Citrahayaan. In our presentation, we will presentation to you about first, overview of well stimulation. The second one is overview of acidizing. The third one is our main topic matrix acidizing, and the last is evaluation of acid treatment. Okay, first, the first topic in this presentation is overview of well stimulation.
Hello, I'm Taufik Hidayat, and this topic will handle by me. Sometimes petroleum exists in a formation but is unable to flow readily into the well because the formation has very low permeability. It can be caused by natural low permeability formation or formation damage around the wellbore. Well stimulation overcomes low permeability by creating new flow channels or enlarging old ones. Wells are stimulated immediately after completion or whenever production drops during the life of the well. The technical objectives of well stimulation are to remove, reduce, or bypass the formation damage, reduce sand production, and clean up the perforation. Formation damage, which can be as a result of drilling, completion, or production operation in the well, can be of three types. The first one, absolute permeability damage. The particulate material block the formation for space, thereby reducing permeability. The second one, relative permeability change, which result in an adverse relative permeability effect in highly water saturated zone, thereby creating significant reduction in the apparent relative permeability to oil. And the third one is viscosity effect due to rock mineral alteration. The economic objectives are to increase flow rates and optimize production from the reservoir. Simulation candidate selection or identification is the process of recognizing and selecting wells that have potential for higher production and better return on investment after the treatment. Selection of the optimum site of a stimulation treatment is based primarily on economic, but the candidate selection process must consider the stimulation budget, treatment cost, initial increase in production rates, additional reserves that may be produced before the well reaches the economic limit. Rate of production decline before and after stimulation, and also reservoir and mechanical problems that could make the treatment to be unsuccessful. Several techniques for selecting simulation candidates exist in literature and also in industry.
Hello, I'm Lydia. The next our topic is overview of acidizing. Oil and gas operators have used acid treatment to improve well productivity for almost 120 years. Acidizing predates all other well stimulation techniques, including hydraulic fracturing, which was not developed until the late 1940s. However, until the early 1930s, acidizing used well limited by the lack of effective acid corrosion inhibitors to protect the steel tubulars in the wells. With the development of effective corrosion inhibitors, the use and further development of acid treatment of oil and gas will proliferate, leading to establishment of the well stimulation service industry. Today, acidizing is one of the most widely used and effective means available to oil and gas operators for improving productivity of wells. Acidizing is commonly performed on new wells to maximize their initial productivity and on aging wells to restore productivity and maximize the recovery of the energy resource. If the formation is composed of rock that dissolve upon being contacted by acid, then a technique known as acidizing may be required. Reservoir rocks most commonly acidized are carbonate reservoir, limestone, and dolomite. Acids that are strong enough to dissolve rock are often strong enough to eat away the metal or the pipes and equipment in the well. Therefore, acidizing involves a compromise between acid strength and additives to prevent damage of equipment. Acidizing involves pumping acid into a wellbore or geologic formation that is capable of producing oil and or gas. Acidizing operation basically consists of pumping from 50 to 1,000 of gallons of acid down the well. The acid travels down the tubing, enters the perforation, and contacts the formation.
Hello, I am Yuliana Citrayan. The next presentation will handled by me. There are other general categories of acid treatment, acid washing, acid fracturing, and matrix acidizing. In acid washing, the objective is simply tubular and wellbore cleaning. Treatment of the formation is not intended. Acid washing is most commonly performed with hydrochloric acid (HCl) mixed to clean out scale, such as calcium carbonate, rust, and other debris restricting flow in the well. Matrix and fracture acidizing are but formation treatment. The purpose of matrix or fracture acidizing is to restore or improve an oil or gas well productivity by dissolving material the productivity formation that is restricting flow or to dissolve formation rock itself to enhance existing or to create new flow path to the wellbore. Two key factors dominate the treatment selection and design process when planning an acid job: formation type, carbonate, sandstone, or cell, and formation permeability, the ability of fluid to flow through the formation in its natural state. The method for both acid fracturing and matrix acidizing are the same, except for the amount of pressure applied. In the presentation, we will invite you to discuss about matrix acidizing.
Hello, I'm Yandridol Fratwarat. I will explain you about a main topic. It's matrix acidizing. Matrix acidizing is a chemical stimulation technique which involves the injection of an acid solution at pressure below the pressure of the formation to enable improved protection by eliminating the formation damage. Acid treatment involves pumping highly pressurized acid into the well thereby dissolving sediments to improve permeability. This process forms channel through which the hydrocarbon may flow. The acid travels down the tubing, enters the perforation, and contacts the formation. Scanning electron micrographs showing pore filling plate before and after exposure to both regular mud acid and sulfuric acid. The most common acid employed to stimulate protection is hydrochloric, which is useful in remove calcium material from reservoir and well used in carbonate acidizing. It will dissolve calcium carbonate, dolomite, siderite, and iron oxide. HCl is strong and hazardous acid, highly corrosive to iron and steel. Hydrochloric acid might be combined with hydrofluoric, which dissolve silica paste from the reservoirs, and acetic acid also better result in carbonate reservoirs.
Hello, I'm Sabrina, who next presentator on this topic. First, if the formation is extremely hot, above 250 Fahrenheit, or when formation conditions make a weaker, less corrosive acid, more desirable, the acidizing contractor frequently uses a solution of acetic acid and formic acid. The second, other acids that are sometimes used include sulfonic, nitric, and hydrofluoric acids. The last two are costly and very dangerous. The third, acids are diluted in water. The concentration range from 3 to 28% acid by weight, depending on the type of acid and factors such as reaction time, corrosion hazards, and emulsion forming properties of the crude oil. Let's see the presentation slide. That's table that show us about recommendation acid type and strength for sandstone acidizing, and the right side is recommendation acid type and strength for carbonate acidizing. McLeod had observed and presented a guideline to the selection of acid on the basis of extensive field and laboratory experience. The major issues that determine design of matrix acid treatments are the reservoir characterization, which comprises the understanding of formation mineralogy, permeability, porosity, and reservoir fluid dynamics. Formation damage assessment in turn includes laboratory analysis, fluid compatibility, and core testing. As a general basis, the treatment normally follow this procedure. First, pre-flush. A pre-flush phase to dissolve sodium, potassium, and calcium ions that will have reactions with the silica, forming insoluble silicates. The second, main acid stage. A main flush phase to dissolve the silicates, quartz, feldspar, clay, as well as the undissolved carbonates after pre-flush. The third, post-flush stage, an after-flush phase to remove the spent acid to keep the wettability in its original state and clean the formation. The fourth, diverter stage. In practice, acid and diverting agents are pumped in alternating stage. First acid, then diverter, then acid again, then diverter, and so on. The number of stages depends on the length of zone being treated. Typically, on acid diverter, stage combination is planned for every 15 to 25 feet of formation. The next is repeat previous stage, and the last is final flush.
Hello, I am Francina Ulana Mary. The next presentation will handle with me. Brine and acid previously and stored in the accumulator are pumped and heat up according the test procedure and particular condition. Via the tubing, the water and flow through the core samples within the core holder. The core sample can find inside the core holder with a detoned sleeve by hydraulic pump. The spent acid get red and measured in the beaker at the end of the process. The back pressure private of nitrogen supply via the Teflon diagram BPR maintain the CO2 in solution. During the matrix acidizing experiment, the flow rate, temperature, confined pressure or overburden, and back pressure are decided maintained constant. The differential pressure at the core during the process in measured my enolate pressure, predicted and recorded in my the review software to construct and analyze the acid response curve. All the equipment reset inside a laboratory ignites system to fan the acid flame.
Okay, hello, I'm Hasna. We're moving to the last hour topic. After doing matrix acidizing, we need some evaluation to determine whether the matrix acidizing was successful or not. There are several parameters of success that can be observed after matrix acidizing work. If raising some of these parameters only slightly, it can be said that the stimulation work is less effective and uneconomical to do. Some software can run matrix acidizing data validly. However, an engineer can validate the values by manual calculation. First, evaluation based on increased permeability value. Second, evaluation based on increased productivity index. Third, evaluation based on increased index performance relationships. Fourth, evaluation based on decreased skin value. And the fifth, evaluation based on increased production rate. From all the things we explained to you about the matrix acidizing, we can draw a conclusion. One may feel overwhelmed by the details in executing successful acid treatments. This is true of any complex oil field operation such as cementing, perforating, gravel packing, or hydraulic fracturing. Acidizing has often been treated with a cauliflower attitude because the treatments can be relatively inexpensive in some areas. Past acid treatments have been successful without much care. That was true because completions were so bad in the early days of acidizing that some production improvement was fairly easy. Today, completions are much better planned and executed, and there is less tolerance for poor stimulation process. Experience with acid in a field is a starting point. If a particular formation or reservoir has a history of successful acidizing with a particular system and products, many of the recommendations herein may not be necessary. Modern completion analysis program can evaluate the success of past jobs and can establish whether improvements are needed. Okay, everyone, that's all our presentation. Thank you for your attention, and we are also big thanks to our lecturer of field stimulation, Mr. Edi Untoro. Goodbye and see you.